see if it's streaming. Going to continue to build the poker tool today. Put some music there. I think I didn't do much since the last time. But I did a few things, and this is what I wrote down here as a plan for now. So I'm gonna use this file, create the standard bets from this file, and then I'm gonna make it so that I can add additional parameters that are gonna limit the size of the bets on the end based on the preference. And then I'm gonna use the standard sizes to create a template of a simulation in Pio, and then after that create scripts that uses the Pio ranges that gets a simulation from Pio, and then uses that to understand the frequencies of how to update the frequencies of the class. Yeah, so what I did here was separate the node ID into flop, turn, and river, and then I put that into a function, and also abstracted away this function to get the player's information in the beginning. And here I'm using these conditions to verify. I'm still not sure if that's the best way or not. But I realize as well that the bets are gonna be always different, because if it is a call, then it's gonna be a C, and it's gonna be a string instead of a number. So that means that whenever there is a bet and a raise, is gonna be, the values are gonna be different. So I can test if the bet is on each thing, each array or each list of each player. And if it is, that means that it is from that player. So that's why I'm making this condition here. And then I'm testing to see if it is a donk. If the type is a float, which means that it is a bet, then, and it is the first element, then it is a donk. If there are other bets, then it means it's a raise, and if it's the first, then it's a bet. And then I update the values based on whatever I get from here. So this just selects which ones I'm going to update, then I use this to update. And then I do the same for the villain here. And then I'm thinking about whether or not I should put this into a function, which I think I should probably put, but then the turn is going to be different than this one. And the thing is that I don't want to spend a lot of time. Maybe I'll do that later. But I just want to build the things that I'm going to use first. And this string here, I'm not really sure as well if it's necessary. Because I think I started doing this thing for a different reason, and then I decided to change later. But then I think I'm gonna keep the string, because the purpose of the string is to just create the node ID with the bats. And the way that I'm doing the bats here, that I'm formatting, I also changed, I multiply by 100 now. I'm using this thing here to get the node ID. And I'm multiplying every bat for 100, so I get an integer value. Because that's how it works in Pio there. So, and here the difference is that I'm gonna put the bats in the format that it asks in Pio on the node ID, which is a cumulative value. So the turn is gonna have the value of the bats plus a baseline, which is the maximum bet from the flop, which I'm gonna do now. I forgot to put the timer. I think I'm gonna spend 1 hour and a half. Maybe I'll spend more time and then I'll take a break at 1 hour and a half. So here, put this. And this part I'm not really sure. As I should just make one string here outside and then add everything to this string, I think. Instead of doing turn string and flop string. And here has should be a leaf. So this returns 3 different lists. Each one has the actions from the flop and turn and river. And I'm separating because I need to get the max bet from each one. Then once I have the bets, and I think the reason why I was doing this with the node ID is because of the search pattern. But I think I'm gonna end up doing that on another file. So I need to convert to the node ID of each thing. So I get the exact path, and then I use that node ID on the class to search for to update the tree according to the path that it was taking on the hand. And the biggest challenge I think is figuring out the frequency, how to update the frequencies. Because it gets very complicated because every range is connected to the other, from the flop to the river. And all the actions, because the actions have to sum to 1, because they're probabilities. But then each range is gonna cascade into the other decisions of the tree. So how to update like every single hand, I'm gonna have to create functions for that separately, I think. Yeah, but I think here maybe I'll do outside here. I don't see why I did it like this. Another ID string. And then I just add to this. That way it's gonna have the whole thing there. But I'm not even sure if it's better to have the string or to have the list, because I think I'm probably gonna have to... I think it might be better to just have the list instead, because I'm gonna have to loop anyway and find the specific decision. So I think that this is probably not relevant. I can just use the flop, turn, and river list, or even the original one to search. So here I have changed to turn as well. Now is the different thing. Yeah, I have to put a baseline here. I think I put here. And this is gonna be the max, but this is the thing that I'm not sure, because if I just put flop here, I'm not sure if it's gonna work. Because the flop can have strings as well. So I think I'm just gonna run this before. Let me check if there's anything. And then I'm just gonna add the bet. Like before putting here, I can just add to the baseline. And that way, I think that's gonna work. So what I want to get at the end is the data structure with all the bats for hero and villain. The other thing that I was thinking about, doing in position and out of position. So I created a different function and got values, but then I think for this file is not worth it, because what I want is just the bats for each thing. But that's another thing to think about, because obviously the simulation is going to be in position and out of position. But I want to classify as hero and villain, I think, because I want to get the... Like, I want to be able to change which bats I use. So I can use my own bats that I do in game based on the data, or I can put some standard bats. And that's another thing that I can just... Ideally, I will have something that I can choose if I want to select the different bat sizes than the ones used on the data, because otherwise you're just trapped on the bat sizes that are used on the data to create simulations, and maybe you want to test some other bat size that you never use or never see someone using, like a very big overbat or something like that. Then, like, you would be able to put here and it would work. But I think I'll think about this later, because I'm going to encapsulate everything to a function, I think, from this point here. Or maybe the whole file. I'll put everything that I have here into a function, because my plan is to import this into another file. And then use this as like the beginning of the next script. I was thinking about studying software design patterns for this kind of thing, but I'm not sure. There probably is, but I'm not sure how to classify this that I'm doing now. Because it is pretty much what I'm doing here, like when separating everything into different files. It's just creating some design, but the thing is that I'm not aware of which design I'm creating. But I have an idea in my mind of how everything's gonna connect at the end. Yeah, so here I have to... No, this is correct. Because it's gonna be... I'm testing to see if the turn action is there, not the turn value. And then I update based on the action string. Yeah, I think the challenge here is later how to make based on the delta, but I think I can do the same thing that I did there with the other one, but I just call delta here inside of the loop. And then I test for each bat if it is within a range. But the way that I'm gonna do, instead of using the delta, I think, yeah, and I think that makes more sense after I spent time thinking about it, is that at the end here, once I get the list of bats that are most frequent, I could just... I'm doing here sorted, so I can just limit based on the length of these things here, or the values. Like, I can make something that only gets the first 3, or limits to some amount of bats for each one. Yeah, but the thing is, I wouldn't return this thing here. I think I'm gonna return the dictionary itself, and then I'll do this stuff later, maybe. So this one just returns... Yeah, that's another question, whether or not to do this on another file. Or to do this here, where the function returns, we have the option to limit the amount of bats. But I think it makes more sense to leave this one just to return the data structure with all the bats, and then I do the sorting or limiting thing on other file. Because that way it allows me to have this file for other purposes if I want to. But I'm not really sure how useful that would be either. So it looks like there's no problem yet. So I think just copy this and do the river one. And this, like I said, I think would be better to put everything into a function. So I don't have to repeat this. But I think I'm gonna leave it like this for now. Because it's annoying to think about the parameters to pass through the function. And maybe I'll do this now, after I test this, just if it works. I think I forgot to change this thing here on the other one. No, turn. I'll be careful to not miss anything. Stern river. Oh, stern baseline. That's why. That's confusing because of the... Oh, here. Maybe it should be river value. It's your stern value. Yeah. River value. And then here is the turn. Oh. Should be river here, so here is wrong as well. And these kinds of mistake that you need to be careful about, because then it's gonna run, but it is gonna be wrong. I think now is correct. Oh, the other thing I realized is that it's not that hard to figure out which is in position and which one is out of position. You just have to get the remainder of the division by 2 because there's only 2 players on the thing. So whichever one acts first is the out of position one, and the other is the in position, and then it's gonna be like back and forth between them. So but I guess in the simulation, I need to, in the range tree here, I need to specify which one is the... Yeah, I need to do something that specifies which is the out of position and which is in position to get the bats. Oh, I think, actually no, I'm just gonna put something here that receives the bats. That's better. On the format that I have there. I'm gonna put some standard bats here, I think. And then from the standard bats I create some function that... Yeah, then the function is gonna take the standard bats and is gonna... The question is, do I do this in the beginning or... I think I'm gonna wait and finish this first, then I'll think about that. So I'm gonna remove this stuff here. I think I left it here because I wasn't sure if I was gonna use it or not. But I still don't know if that's necessary or not. And then let's print this. And so obviously it's not working. This is also really weird. There's something wrong here, probably. Yeah, there's obviously something wrong. It's how is the effective stack 0? Doesn't make any sense. So I am getting the information. Oh, did I forgot to put this stack here? And this is weird because I think maybe when I was moving things, because the other one had the stack. Yeah, now looks better. I think the starting pot is correct as well. And 3 bet seems incorrect. Is this sorted? And the bets obviously are incorrect as well. I'll have to see what I'm doing wrong there. I think it might be the keys. Oh, it's based on the value. 0.5 doesn't make any sense. So it must be something that I'm doing wrong on the parsing. Or maybe just the... But it can't be the stakes because it's 25 here. It wouldn't make any sense. And the single raise spot is... So this has should be 5, I think. Yeah, here's 535. So what's going on? Let's see if I... Yeah, I'm doing this before I do the whole thing of changing the bats. The thing is, if it was the data, how it would be wrong on the 3 bet, but right on the single raise spot? It doesn't make sense. Because it's adding here in the same way, in the same line. So how can I see what's going on here? Because I am getting this directly from the data. There must be something with the data, but... So it's because I'm putting L's there. But I wonder... Maybe it's the link. Yeah, it's the link. When there's a link pot. Let's put hand type. Close link. And then... Because there's limps, there's 4 bats, 5 bats, and 3 bats. Yes. 0.5. Nice, okay, so the data is correct. But that's an additional thing that I have to think about when... I think I'm just gonna do single raise pots and 3 bat pots. Because 4 bat pots is not... even though you can study, there isn't too much... It's not that complicated, I think, to play 4 bat pots. And 5 bats is also the same thing, where it's pretty much all in at that point, so it's not really that hard to play. I think most of the EV comes from single raise pots, and then right after that 3 bat pots. So I think that those are the only ones to pay attention to, or to study more in depth. Because even if you lose EV on the 4 bat pots, it's not that big of a deal, I think. Okay, so let me think. And this stuff here also doesn't matter. Maybe it does actually. I think it does. Yeah, and I'm gonna be multiplying this by 100, I think. So, because I need these things to create... But that's the question, is like... Do I create based on a standard starting pot and thing as well? Or do I use the data? I think I can use the data. And then it doesn't matter if it's a 3 bat pot or a single raise pot. I think I can use the data, and that's probably what I'm gonna do. So I need the effective stack here as well. And the positions I get from the file. Yeah, I think I need to determine before. I'm not gonna determine inside of this class which player is in position and which is out of position. I determine outside, and then based on the outside, I put past the ranges that I think that I want to use for each player, and then I pass the bats accordingly. So I think it's better to have a script outside, and that script determines which player is in position, which is out of position, and determines the bats for each one. And then this class just receives the ranges and the bats. I need to create a heuristic for 3 bats on side of the flop, on side of the street, but I think that's easy also. You just put, if there is more than 2 bats, then it is a 3 bat. So make something that if it's the 3rd bat, then you increase. But that's the thing, I think. Yeah, because the thing is, from this class, what I wanna do is create the whole tree. So I have to take the same inputs that Pio does, and then convert these inputs like into all the trees of all the nodes of the tree. So I need to create something that calculates, and this is the hard part, like how do... I think this part comes on creating the tree, where it's just like figuring out what's the baseline, and it's probably related to the effective stack. So once the bat reaches the effective stack, but it gets tricky because of the calculation to update each bat. I think I have to do this with while traversing the tree here to see how it works. The situation that I'm talking about when you get this 3 bat here, which is the formula that is confusing to look into. What is the... and I think here it goes out. I think it's based on the threshold there. There's a no-win threshold here. And I think I can look at you in the documentation to remember or to learn how this works. So if the bat is 6-7% or of the initial stack, of the effective stack. So if the bat would be, so I guess you can just put a condition and compare. So you apply the formula, create a heuristic, apply the formula, and then after that put a condition. So it shouldn't be... I mean, it's hard, but should be possible. Yeah, so now let me think about why this is not working here. Because the flop turn in river, no, it's working. Maybe it's because of the way that I'm initializing, but I don't think that's the problem. Maybe it is. It isn't the problem. I forgot to... I should put a condition, I think, in the beginning of the hand. That way I'm only gonna get the hands that there is a flop. But it's still not working here. And this should be correct. So I'm getting these empty lists here. Oh, it's because the flop is the bats, not the bar. So there might be a flop, but then there is no bats. But then how would that be possible? Is the way that I'm splitting there. Yeah, so there is a bat here. And this is also incorrect. It's weird because I remember testing this. It's not because there's these indexes here. Oh, this one makes sense because there's no bats. But there's also weird as well. I guess it makes sense because if there is no... Yeah, but there should be a check at least. So maybe it's because of the way that I did the data. I didn't put checks. Maybe that's why. But I wonder if it matters. I think it doesn't matter. Because the thing is that... Yeah, for this situation it doesn't matter, but for the other ones I think that there's something wrong. But I think maybe it does matter because when I'm constructing everything else is going to depend on the checks as well. So I think I need to put here another thing. And that's preflop. No, I did put checks here. I remember now. Yeah. So it is supposed to be there. And just put bats and raises in the same category. So what is going on? I guess it's something with the data probably. Some situation where, for whatever reason, like there are no actions. Maybe when the two players go all in on pre-flop, then it just shows the cards. I think that might be the case. But I think it doesn't matter that much because I think the way that I'm parsing the data is correct there. So, and this is irrelevant to creating the tree, I think. This is just a situation pre-flop. The issue is the other ones though, that I'm not capturing the bats. I might have to figure out a different way to do this. I'll try to print here. Because I'm not getting any actions and they should be getting. Yeah, I'm getting, so it's probably the way that I'm destructuring here. That's the easy way to test. This should do only one and then change. I'm trying to think about a different name to put there. Because here I'm converting the bats already, so it's gonna be different the value, but it should contain the same situations. It's weird that it's different though. Let me think about a name. New, no idea. Just put whatever now. Maybe it's because of the way that I'm doing this here. And it's because of the length. A greater, maybe this thing here. So it's definitely a problem with this function. I think that the other way is probably fine, but I'm gonna debug this first and then I'll revert back to the other way. And the flop only contains the bats here, which is also weird. Oh, this should be 1, I think, or should be less than 2. Because if there's only one element, then we should just make it equal to 1. Yeah, so here is incorrect. No, here is correct, I think. Because here is the indices. So the way that I'm doing is getting the indices where there's a turn and a river. And then I'm using this to split the original list based on the parameters, like the boundaries between them. So here I got the index, if it's not in string action type, different than float. Also, I think I need to remove the first element from the actions, but no, maybe doesn't matter. I don't think it matters because of the way that I'm parsing everything after. Oh, it's because of what I'm returning here. Oh, let me think. And because the length is 1, then that means that only there are 0 exists. There are no indices. I returned the thing, which is the flop. And I'm splitting between the two. I think it's because of the way that I'm filtering here. I think because the flop is getting all the numbers. But it should be filtering the node ID list based on the indices 0. Oh, it's because I'm only passing the numbers. That's the problem. Yeah, because this is not. I'm only. Um, I'm not getting the checks there. Or the C's. I have to do the other way, I think. I forgot how to do the else statement on list comprehension. Hopefully it's gonna work after convert. I'm not really sure if there's anything wrong as well after this. I think the other, like, this is not the problem, probably. It should work like this. So I think the issue must be this stuff or something that I'm doing here, this function. Because of this slices here. But I tested these parameters on the, like, before passing this into a function, and it was working fine. Yeah, let's see if it works now. Let me print the other one first. I guess it changes everything because of the R's there, 0 there. But there's obviously something wrong as well. Yeah, but now it seems like it is correct. It is getting the actions here for the flop. This is weird as well. Here it returns 28, almost 29, but here is 0.29. But I guess when I convert, it's probably when I convert to int, it's probably gonna be the right format. This is another situation where it's probably all in preflop. Yeah, now everything else is working, I think. The turn. I think this is correct now. And this one is weird. Because it's saying that it's a turn. Oh no, it is empty. So it is correct. Because if it has a flop, I'm gonna call the thing anyway. So it's just gonna turn empty. So I think this part is correct. So what else can be wrong there? Let's see. I'll print this to see what values I'm getting. Maybe I have to do keys instead of doing that. And that's the other question I have is what kind of format I should place there. I think I should remove this in the beginning and then add this on the stringing down. Yeah. Or I'll just leave it like this and remove this string. Because I just want to get the bats, raises, and donks. I think I'm gonna remove this stuff here. This node ID string. Yeah, the reason, maybe I'll do that later, but then I'll do it somewhere else. I think I did that because I was thinking about doing something else with this file. If I remember correctly. Obviously this is not gonna solve the issue, so I'll have to see what's wrong there. I think I have to do keys here. Oh, maybe that's the problem. Yeah, that's the problem because I'm testing. I'm multiplying by 100 and then I'm testing here. To see if it is, and obviously never gonna be there because it's multiplying by 100. So how do I do this? It gets tricky because if I divide by 100, like I'm concerned that it may miss the it may miss like the conversion may be different, maybe some bats. Maybe you should just pass node ID here instead, and then convert later. It's probably better. Let me think. Alright, I could just have the values and then convert them later as well. So just pass the bats as they are and then do the whole formatting thing later. But I guess the reason why I wanted to make it like this is so it's easier to create the tree later. Because then I can add the base, I can have the baseline already here. That's why I was thinking about formatting this way. Yeah, the action is different than the string that I'm putting there. I think I'm gonna do it the other way. Let me see, like if I put here, like this. Like then I do the conversion here, where the conversion is just multiplying by 100 the value. And then converting it to an integer. I could just do here. Because then I'm checking a different value here. Yeah, you should add comments as well to make that explicit. It's still not working there. There's probably something else wrong. Yeah, but I think I'm gonna do it like this for now. Let me comment this. Just pass the original one and then I test based on the original one. Because then it's more accurate, because the values are gonna be the same. For this check here. Because this is checking on the actions here. To see if the action is on the player, to see if that player made that action. And it looks like the string is correct as well because it's printing there. Okay, so it's just multiplying by 100 and then I should probably multiply the effective stack by 100 as well. And the starting pots. Let's see if it runs. Oh, now the bat's working, so it is working. Nice. So I think it's gonna work after I change the other ones. And what is this massive number? Not sure about effective. And this is weird. So there's obviously something wrong here. Mine is multiplying. Let me think actually. Why is only working on the flop and on the other ones if I change it here? I should be, but no, because here I'm checking turn action, not turn value. I'm only using the value to update. Now let me focus on one thing at a time. First, so do the other stuff, then I'll worry about this. Maybe it's better to multiply by 100 after I get the effective stack and starting pot from other file. I think like this is maybe it is good to have here. Because it's not the main point of this one. Like I wasn't focusing on this, I just left here because I got from the other script. But I think it's probably worth it to keep, because then I can use that to create. But I think I'll multiply by 100 on the other if it doesn't work. Or I can spend some time figuring out. Yeah, but why is the flop working now and the other one's not? Oh, so raises doesn't work. No, it works on the raises. The donks. Because it's a small sample, then like it makes sense that it would be empty. It just means that nobody donked on the data. Yeah, I think it makes sense. But the other ones is probably because of the baseline, but I don't understand why. Yeah, because the turn flop, the turn list should be the first action from the turn. So the conditions are the same, I think. Maybe I'm not. No, I am updating here. So if there is a bat, then it's gonna be a raise because I'm appending the previous bat to here, which means that this is gonna be true. And if there's not, then it is a bat. Also, it has to be on the villains as well, because I'm only printing villains. Turn bats, villain bats. Or maybe, no, I am changing the... So what else can be wrong here? It has to be, maybe it's the data. He's never hitting this point. It's weird. So maybe it's the problem with the other function again. It's never hitting this. So maybe it is the destructuring thing? There are some turns that have bats here. Oh, this should be if, an if statement, not a if, I think. As well. Yeah, that's the problem. Because if there is a flop, then there is a turn, obviously. But the question is, should I leave the if statements here or just do everything inside of the if flop statement? I think it makes sense to put everything inside of the if flop. But the thing is that it is different because, like, maybe there is a flop, but there's no turn actions for whatever reason. Like, let's say they go all in on the flop. Yeah, on that situation. Then you can have a situation where there's only a flop, but no turn and no river. Like, no actions, but obviously you would have the turn and the river. Just no actions. Yeah, but I think that way... I think the problem is that I'm putting a leaf here. It should be if. But I think it's worth to leaving as if. And not putting everything under the flop condition. Let's see now if it works. It would be good if I had more data as well to test. So this is a string. And this is the other problem that I had. So I think I can filter based on the... And the question is, what is the best way to do it? I obviously have a filter based on the... on the list of the flop to get the bats. So it's a situation, let's put defaults 0. Let's see if this works. So I also need to put defaults, but then I need to filter based on the values. So I can either do a list comprehension or I can use the filter function and then list. Let's see if this works. So it works. There we go, finally. I think this is likely to be correct because here there's donks, and here there are no donks, but it's because there isn't too much data, I think, with the hands that I have here. So the issue is verifying the bats. I think the bats are not correct. Oh, this set should be multiplied by 100 here. Maybe it is correct. Yeah, but it's kind of hard to tell, though. No, but I guess it's only one. Let's see. And this is a raise, it's not a bat, so I think it's likely to be correct, actually. I think it makes sense. I think this makes sense. So instead of doing all of this here, I think I'll just delete all this stuff and then put this into a function. I think it is correct. I don't know how to test for this though. As far as I can tell here, is I'm adding based on the baseline, and those are the actions without converting them, and then I convert only to put on the string there. And I'm basing it off on the 2500 that it would be the effective stack, if the sizes make sense or not. And because there isn't a lot of data, I think it's hard to know, because obviously there can be a lot of variance on the size people use. Now let me see if I can solve the starting pot and effective stack, to see what's going on there when I multiply by 100. First, I think I'm gonna remove all of this stuff here. I think I'm gonna leave it like this. Maybe I'll change in the future, but as far as I can think, everything seems to work here. And then I'm gonna put everything inside of a function. The other thing that I obviously can change is to put this stuff on a function as well. The logic here, and then just call the function instead. Which I might do, but I think I'm gonna do that off stream. Maybe I'll do it, maybe, because I wanna get to the point where, for the more complicated stuff, where I'm actually getting building simulations. And then I think once I hit that point, then I think about refactoring everything and making everything like better. I think it's better to get to the point where I have stuff first before thinking about this other things. I should print the account here at some point. I think I'll print at the end after increase or here, because it might skip hands. So now I'm gonna put everything on this file inside of a function, and then I'm gonna see if I can call this on another. I'm gonna return the values there. I think it's gonna be annoying because it's gonna be a dictionary of dictionaries and like very complicated data structure. But then I can figure out on the other file. Once I return that, I can get those bats and I can start working on this one. Yeah, so I'm gonna have my bats, their bats. And then I'm gonna use that as a template for all the simulations. So it doesn't matter which position it is from this file point of view. Yeah, I think I wanna build everything first, and then I worry about the rest. Because there's the issue with the flop frequency and how to optimize the data to get the most out of it. But I think I need to build the simulation first and like build the structure of the class first, doing all of these things, and then I worry about this stuff. So I'm gonna need the positions, I think. Maybe this class. No, I think it doesn't matter the positions for this class because I have the ranges. So all I need is the ranges, the flop, effective stack, starting pots, and starting node ID. And then I should be able to build everything else with this. Oh, it misses the only thing that is missing is the bats. So maybe I'll put in the end here. I'm gonna have to do it like this because there's too many. And this is gonna be the data structure that I'm returning from this file. Yeah, and I think instead of let me think. I think I have to separate between in position and out of position. The question is, when should I do that? Because I'm gonna have to determine that before, so I think the way that I should pass through this class should be for in position and out of position, obviously, because of the way that the simulation works. But then I need to know beforehand, because here it's better to know if I'm on, like, what are my standard sizes and their standard sizes. Because that's never gonna change. And then the positions change all the time based on the situation. So the first thing that I need to do, I think, is to get the positions on the order script, and based on the hand. And then from that I get the bats for each one. I use this file to get the bats. And then depending on which one I'm at, I'm gonna have to think about parameters here as well. No, it's complicated as well. So obviously I don't want to use all of the bats that I have here. It's too big, so I need to figure out how to put parameters that allow me to determine how many bats to include. And I think if I want to select other bats for myself, then I think maybe it's better to do it on another file. is let's say that I always want to have like always bet 50, 75 and 150, so, for example, on one of the streets. Then instead of using my data, I can put these bets instead on the other one. But I'm not sure. I think it's better to do it on another file, I think, rather than doing it on this one. Let me think. Let me put first everything on the function. And this is the one that I'm not really sure if I should use or not, because I was using this on the other one. I think I'm gonna erase them. If I want, I create another function. Should do that. The questions of design are very difficult to think about, because it's a lot more subjective than the questions of like the building blocks of the functions itself. Because I think the higher the scale of complexity that you go, like the more volatile things become, because it's like there's a trade-off in, it's like connected to space-time in the potential that you have for different things to happen. So like the bigger the scale, the bigger the variance you have. I guess it's related to density instead of scale. Like the higher the density something has, the more certain it is, so the less complexity you have. Not less complexity, but like the less arbitrary it becomes in relationship to a reference frame. Because the density is just the determination of how frequently things change. So the higher something the more frequently something changes, the more volatile it becomes, and the harder it becomes to design that thing, because then you can obviously change all the time, and because like the thing that I'm doing here, I'm not really sure, like it's hard to envision what is going to be the best way at the end to create the structure of the study. Like the simulations and related to the data that I'm getting, that's the problem. And this is why it's so hard, because now I'm thinking about like whether or not I should build the class. I think I shouldn't build the class and incorporate these functions into here, and then create another function inside of this to encapsulate this code here. Like, and I think that's the difference between objective-oriented programming and composition. I think if I created a class, it would favor more composition. It would favor more object-oriented, but if I leave it like this, it favors more composition, because composition is more dynamic and you have more, it allows for more variance, and then object-oriented programming is more rigid and fixed. And then there's the distribution of the two, which is always the case in everything else. And I think that's just the funnel of information. So composition is like the base of the funnel, it's more chaotic and has more potential. And object-oriented is more fixed and rigid and is at the top of the funnel. And the flow of space-time is the conversion between the two that works on a wave function, which is the relationship between the electromagnetic field and space-time, which is the pattern of gravity, the frequency of awareness. So any solution, I think that is the best solution, is going to incorporate the distribution of the two, depending on the context of space-time, based on the flow of information, which is the data. So the data determines the patterns of our algorithms based on the structure of this connection between the electromagnetic field and space-time. And the higher the scale, or the higher the lower the density, the higher it becomes to find a pattern. But then that's like, it goes again, like, I think the lower the density, the more composition, and the higher the density, the more object-oriented programming. But then the challenge is on the middle, obviously, always. Because that's the essence, I think, of space-time. Of information is the flow between the two. And because of that, that's where it gets really challenging to figure out what is the best structure to design all the files. And it's also because it's really hard to think about the overall problem that I'm trying to solve. The overall structure of everything while I try to fix these problems that I'm having on each file. Because everything is interconnected. So if I change here the way that I do, and this is the biggest challenge, I think. Probably not only on this project, but on every other project, is that when I'm designing the functions here, or this function to create this data structure to use on another file, then I'm gonna use that on this class here, and then depending on where I decide to put the boundaries or the format of the data structure for the connection between files is gonna change the whole design of everything. And then like it might, and this is the biggest problems, because it might be the case that it works really fine, but then like 2 years later, where I want to do something else with this or something like that, then I realize that I made like a significant mistake on one part of the code, and then it breaks down everything else. Not a significant mistake, but it like is a slight mistake in the way that I was thinking about the format of the data structures and the flow of information, that it makes me have to change everything else. And this is why I think it's worth like spending a lot of time thinking. I think those is probably the most important decisions I think you take. It's figuring out what is the best formats, the best data structure, and the best flow between the files, the best software design thing. But it's a hard thing to study as well, because it's one of those things where it's because it's just a different level of complexity, I think. Because it's the same thing with trading and everything else. It's the line between art and science, where because the conversion towards a Nash equilibrium of infinity, like, is the gradient of distribution of objectivity and subjectivity, where as closer you get to subjectivity, the more blurry it becomes Nash equilibrium. So everything is going to be like this conversion towards what is considered to be objective, which is just a higher density of space-time, and what is considered to be subjective, which is lower density, which means that it has more variance than everything is always going to have a pattern. It's going to have patterns that work, but the patterns don't tell you everything. And then the process of becoming good at that thing is getting more and more experience over the context that doesn't encapsulate the data. And it's just like in poker as well, where it doesn't matter really if you have the data, because it's all about the context of each situation, and the edges you gain is by gaining experience over the nuances. And it's just like in trading, like if you just read the patterns on the chart, you're never gonna make money, because it's like you're assuming that the thing is going to repeat itself exactly the same, and it's not going to be exactly the same because it's going to be a fractal pattern. But then the more experience you have, the more you are able to catch the nuance, which is the conversion between objectivity and subjectivity in relationship to a reference frame, that allows you to have more higher accuracy on the nuance spots. And I think that's the evolution of the equilibrium. Just like the higher the computation, the closer you get to the actual essence of the fractal, the mutafractal, which is a geometrical structure in space-time. just leave it like it was before. So here I should return these two things here. Return a dictionary that contains them. It's gonna be standard bats. That should be outside of the loop. And I have to think about the parameters that I need to pass. Yeah, so now, like, I'm gonna upload or import this file into another file and create another script. Which is gonna be the second step here. This is standard bats to create template tree file to determine. Necessary functions to create tree and add lines. This is standard bats to create template tree file. And this part is gonna be really hard. So I have to think about as well the parameters here if I'm gonna pass anything. Like how I'm gonna filter these things in the... Yeah, it has to be at the end here. So at the end of everything I do something here. That it navigates hero bats and villain bats based on the parameters that I pass and filters them. I'm probably gonna use ChatGPT to do that. So I just need to get these dictionaries and ask how to filter them. I'm gonna do that now. I think I shouldn't return the dictionary. I should just return the bats. That's a lot better. Yeah, I'm gonna do that. Even if there is no filter, then I can just change based on the parameter. But it's probably better to return just the bats. Because then it makes it more simple on the other script. So here just return like a list with the bats. In order of the frequency. Or not even in order because it doesn't matter. It's just the bats that I'm going to use on the simulation. And then the frequency is determined by the parameters. So I'm going to do that and then... And then based on that... based on this bats, then I create the template of the... And the lines is just going to be the tree traversal. The add lines for the Pio script. Yeah, so I'm gonna figure this out. Well, maybe I'll do... Maybe I will come back today. I don't know how long it's gonna take, but... Yeah. If I did... I think I'm gonna come back today. Like, after I eat something and take a break. And then I'm gonna continue to do this. I think when I come back I'm not gonna put the camera because it's easier. Yeah. It's easier to think if I don't have the camera. So yeah, but that's what I want to do now. Is I think before I create the other stuff, I'm gonna figure out the parameters and then just return the bats based on the parameters. Probably use ChatGPT. Once I have figured this out, then I'm gonna create another file, and then I'm gonna import this file and call this function, and then with the data structure, I'm gonna use this range tree here to build the tree based on the bat sizes for each one. So yeah, I'll probably come back today after I take a break. And if not, for whatever reason I decide not to, then I'm probably gonna come back tomorrow. So yeah.